All right, it's 5 p.m. I will slowly start, and to first say, welcome everybody to this KNIME webinar about spaCy as a low-code extension for NLP. As we slowly go into the webinar, before we actually start, I would like to remind of a few important points, especially if you have questions during the webinar. How can you ask questions? There is a dedicated Q&A tab in the lower part of your of Zoom, and please type your questions there. We'll make sure to answer them during the webinar, but also at the end during the Q&A session. And now we can start going more into the, let's say, into the topic of today. And I'm very pleased to start introducing our speakers for today. Our first speaker is Raphael Mitch. He is a machine learning engineer at Explosion. Explosion is the company that develops and maintains spaCy. So I'm very happy and honored to have him here. He has been working on different, let's say, aspects of the development of spaCy, but also in many other NLP projects. And recently, also in how to integrate LLMs in spaCy. So welcome, Raphael, and thank you for being here with us today.
Happy to be here. Thanks for inviting me.
Thank you. And our next speaker is Artyom Ryasik. Artyom is an advanced analytic engineer at Redfield AB. Redfield is the company that allowed basically the use of spaCy in the form of an extension to all KNIME users. So we have an extension that sort of wraps this spaCy capability and make it available to KNIME. So Artyom has an academic background in life sciences, but he also has been working on several projects in recommendation engines, NLP, graph analysis, and last but not least, he was nominated Contributor of the Month in July 2023. So thank you for being today with us, Artyom, and it's a pleasure to have you.
Thank you for introduction. Pleasure to be here.
Thank you. Okay, and lastly, it's me. I am a data scientist at KNIME. I have been working mostly in NLP and computer vision, and also I'm currently one of the editors of Low Code for Data Science, which is non-community journal on Medium. Let's have a look at today's agenda. All right, so we're going to start with an intro to spaCy by Raphael, who is going to talk us or tell us about more what's spaCy, how spaCy process and understand text. So we make sure we don't miss a single important point about the spaCy library. Next, we understand and we introduce how the Redfield NLP nodes, that's the name of the extension, that allow us to use spaCy capability in KNIME. So we'll see what those nodes are, how they were, let's say, created, and more details about it. And next, we move to spaCy meets KNIME, so a section where we're going to show you some use cases. So this is a part where Artyom is going to introduce some use cases in NLP that combines the spaCy nodes with KNIME Text Processing nodes. And finally, we're going to have a look at what's new, both in terms of spaCy, so what's in their say roadmap for the future, and also KNIME roadmap for the future, especially when we talk about LLMs. So what is possible and what can we expect? And finally, we're gonna let's say wrap it up with some questions from the audience. All right. So as I said, the first part is going to be an intro to spaCy, about how and in which way, let's say, spaCy understands and processes text. So I would like to leave the stage to Raphael. So please, Raphael, take it away. It's going to start sharing.
All right. I'm going to share my screen. So I hope you can see my screen, Roberto.
Yes, we can.
Okay, excellent. All right. Yeah, as Roberto already mentioned, I'm going to give a short introduction to spaCy. So what is spaCy? It's a customizable natural language processing toolkit designed for developers. And before I go deeper into that, I have to give credit where credit is due. I stole those slides from my colleague and team lead, Sophie Van Landegem, and just slightly adjusted them for today's webinar. Right, so the first part I'm going to start with is a general introduction to spaCy, and the second part, as Roberto mentioned before, that will be towards the end when we talk about new things in the roadmap and new developments in spaCy. So what is spaCy? Well, it's an open source library for all kinds of tasks for natural language processing. It's one of the most popular open source libraries in this field, and has a focus on production use and developer productivity, which is kind of in contrast to many other libraries in that field that focus more on getting latest state-of-the-art models as quickly as possible, and focus more a bit on the research side of things. And if you're interested in giving spaCy a closer look, we do have a pretty neat online course that you can look at course.spacy.io. A core concept of spaCy is the pipeline. So you do have a lot of different tasks in natural language processing. So a very useful abstraction for that is to look at those tasks and the dependencies of those tasks, and then create a pipeline with different actions, basically. For example, one of these actions might be tokenization, basically separating natural text into different tokens, basically different words. And after that, you could have stuff like, in this example here, a tagger that analyzes and infers the kind of those tokens, whether it's a verb or a noun or pronoun or whatever. A parser that kind of infers the relationship between tokens, and something like named entity recognition. Basically, if you have important terms, also multi-word terms in your text, like the name of university, the name of a person, a company name, all kinds of things, then this kind of component could do that. There are all kinds of different components in spaCy, so these are just like 3 or 4 that are more or less arbitrarily chosen. But essentially what happens is you have your text, you build your pipeline, the text goes into the different stages of the pipeline, and on the other side of it, you get a document object. This is basically text enriched with all of these additional information. So one of those goals, as mentioned before, of spaCy is to empower developers. So the way we look at this is that usually in very broad strokes, you have 3 different phases here in the life cycle of a machine learning project. The first one is to understand the business case. So what is the business case about? What is actually the goal? And then choose the technology and the tasks and the whole rest of your project based on that business application. And from there, from the business case, go to the downstream needs of the natural language processing solution. So what do you need for that? How you can actually implement that? Then you transition to the to the prototyping phase. In the prototyping phase, what you want to have is you quickly want to have a functioning solution. It doesn't have to be a perfect solution, but it should work, and you can iterate upon that. So for that, you want to use some of the pre-trained models. Ideally, you don't want to train everything from scratch. So spaCy provides a lot of pre-trained models in, I think, like 24 languages at the moment. And spaCy also offers a lot of built-in functionality and sane defaults, meaning that you don't have to tinker too much just to get something going and just to get decently good results. Finally, once you're past this prototyping phase and you have demonstrated this works in principle, usually you want to improve upon that. You want to customize the solution, you want to be more precise, more accurate, faster, whatever. For that, spaCy offers the ability to implement custom models and algorithms. It has a powerful configuration system that makes it quite easy to change hyperparameters, to change different kind of settings for your spaCy solution. And all of that together allows you to fine-tune your spaCy solution iteratively, instead of having to work on a perfect solution from the get-go. Regarding pre-trained models, spaCy, right, there it is, 24 languages. We offer pre-trained models or pre-trained pipelines that have a certain set of features. So you will have to, if you want to use one of those, you will have to accommodate or be okay with the feature set that these models offer. But the other side, the upside of that is that you can just like do all kinds of natural language processing tasks from the get-go without ever having to worry about configuration or setup. We offer those in different languages. So the general structure of those pre-trained models or model names is that you have the language, you have the corpus, and you have the size. The size is it's a small, medium, large, or a transformer-based model. Basically, the capability of these models increases with the size, not very surprisingly. So it's up to you and your business case to decide between the different sizes that are offered. And we have for different languages and also partially for different corpora. Usually it's one corpus per language, but there might also still be cases where we offer models trained on different corpora for different languages. So if you use one of these pre-trained models, what you can do is, for example, as you see down there, in this case, it's entity recognition. So what these models do is recognizing entities in a natural language text and identifying those for you. And this is a task that happens very often in business cases as a kind of stepping stone for further downstream tasks. A more realistic use case is that, for example, clinical trial results, you have a lot of complicated text, and the pre-trained models can't cover it very well because clinical text, as in many other actual use cases, is rather special in its vocabulary. And there are particular kinds of entities that you want to recognize in that. So pre-trained models won't do any good here. So with spaCy, we can also train supervised models, of course, so we don't have to rely just on the pre-trained models that we offer. So we need to identify what do we want it to do actually. In this case, we want to identify patient groups, drugs, doses, frequencies, outcomes, and other stuff that is very specific to clinical trials. That is one thing, and then we also want to identify and extract relations between those different patient groups and treatments, like which patient group got which kind of treatment over how long, etc., etc. This graphic, it's visual at the bottom, is just a summary of how the training process works. I think I'm going to skip that. We can still come back to that later. To train properly, we do have to annotate our data. For this, shameless plug from my side, Explosion, so our company that also makes spaCy, we make an annotation tool called Prodigy that is very well suited for this kind of text annotation tasks. And comes with a lot of built-in functionality for all of these specific use cases. So here you see how this would look like if you annotated this clinical trial text with Prodigy and you did the labeling for entity recognition and the labeling for relationship extraction. And what you have on top of that, once you have the data, you will have to write the configuration. spaCy can give you a kickstart here. There are commands for basically generating a config, and then you just have to adjust this pre-generated config to your liking. This configuration system is quite handy. It's rather simple and intuitive, in my opinion. Obviously, I'm biased. But you basically get a configuration to start with, and then you can just adjust it, and in that way, modify the properties of your model that you want to train. And finally, once you have all that in place, once you have your annotated data, once you have your configuration for the model you want to train, you can use another CLI command that spaCy offers to just, as you can see here in the line at the top, a simple single command to kick off the training. spaCy will train the model for you and will store that model, the trained model, in a format that you can easily load it again somewhere else for spaCy. So basically this whole model is packaged and you can install that in your Python environment, or you can use it just like you can use the pre-trained models. So this was a very quick rundown of spaCy. I think I've touched like probably about 5% or 10% of all of that what's there. But I hope it gives you some sort of impression and insight into what spaCy is, what we set out to do. And yeah, I'm happy to answer further questions in the question sections at the end. Sorry, question section at the end. And back to you, Roberto.
Thank you, Raphael. Thank you very much for introducing spaCy to us. And then I will then go further with our agenda. So, second. Let's move on. All right. As we mentioned in the beginning, in the agenda, we're now going to move to the section where we explain how we can, let's say, leverage the power of spaCy library in KNIME. And we can do this with the Redfield NLP node extension. And so let's have a look at this. Before actually we do have a closer look at the nodes, I wanted to just stress how amazing this, let's say, how the collaboration of open source tool, how amazing this is. And it's sort of an open source love story. We had Explosion that developed spaCy, an open source library for NLP that targeted originally users that want to use it in Python. And then we have Redfield, our KNIME Trusted Partner, who developed the Redfield NLP node extension to use, basically, to bring the capabilities of spaCy to KNIME users. Also, in this case, it's an open source extension. And obviously, KNIME that develops KNIME Analytics platform. If you're here, probably you know already what KNIME is. And so where you can basically use and build your pipeline in a visual programming, with a visual programming-based paradigm. And that's in fact also another story, right? So it's not only an open source love story or a way to basically show how an open source ecosystem can easily integrate with other tools and library, but it's also a story of how you could, how a project or a library that originally targeted Python user can now also be used by a user that prefer a visual programming based approach. Or if they want, they can also combine both of them. In fact, we started with a Python script, so in Python. So to use, for example, the spaCy library, as Raphael already showed us, we moved to a Python-based extension. So the Redfield NLP nodes were written in Python. And we end up with a visual programming-based workflow that uses basically the nodes in KNIME. All right, let's have a closer look now, as I said, at the Redfield NLP nodes extension. There are about 8 nodes in total, and they do basically, they leverages or they allow the user to use basically the capability for text processing and extraction that the spaCy library offers. One of the first and probably one of the most important node in the extension is the spaCy model selector. As Raphael already mentioned, there are many different trained pipelines, basically each of them corresponding to a specific language. There are about 25 languages and that can be, let's say, used as pipeline with this node. Some of those languages, for example, are not included in the native KNIME text processing extension. So with this extension, you can, let's say, enrich and expand the capabilities that you have within KNIME for your NLP tasks. For example, languages such as Korean or Catalan can be, let's say, now can be accessed or you can work with thanks to this extension. And as also Raphael already mentioned, there are different pipelines. So those that were trained, for example, on the web or on the news or in different sizes and different, let's say, pipelines that some use static word vector tables and some other use transformer models. So here you see on the slide the simple configuration of this node where you just basically select the size and the language, and you're pretty much good to go. And as I mentioned, there are other nodes as well. And for example, the spaCy tokenizer, the spaCy name entity recognizer, or the spaCy post tagger. With this node, we can do a series of operations for tokenization and enrichment. As you can probably imagine already, the spaCy tokenizer, what it does, it's basically segment our text into tokens, and it's similar to a certain extent to what the string to document node does. So at the end, we obtain a tokenized text that is in the document type object. That is the standard object to work to process text in KNIME. We also have a spaCy name entity recognizer that allows us basically to leverage this pre-trained model and assign entities, for example, for persons or for locations or organizations. And last but not least, in this little section, we have the post tagger. Here, obviously, what we do, we assign basically part-of-speech tags. And as you can see also from the slide, the configuration of these nodes is very, very minimal, very simple. You only need to input the column that you would like the node to operate on. So very simple configuration. And we also have a tab here, Python, that if you want, you can point a node to a Python environment, to a conda environment, basically you have special packages, so you can even further expand the capability of that node. We also have nodes in this extension for pre-processing. For example, a spaCy lemmatizer or a spaCy morphologizer, or even a spaCy stop word filter. What is the difference between a lemmatizer and a morphologizer? Well, the lemmatizer basically converts the word into the root form. We will see an example later on. And a morphologizer basically assigns spatial grammatical tags. For example, it tells where is the tense of a verb, or if it's a word, the noun is in a plural or singular form, and so on. And obviously, the stop word filter node, the spaCy stop word filter node, what it does, it obviously removes stop words from our text. And the last node that we have in this extension is the spaCy vectorizer. What this node does, it transforms basically our text into numerical vectors. So basically, it generates word embeddings. Okay, very simple, and also in this case, very simple configuration. And here is a little workflow example that shows some simple text mining operations using this all those nodes that we have just introduced. In this case, in this example, we have a table reader where we import some text in Portuguese. Those are just news about some earthquakes or tsunami that happened in the past. And the first step, of course, is to basically select the pre-trained pipeline. So we use a spaCy model selector, as you can see here on the slide. In this case, it's a test in Portuguese, so we select the model here in Portuguese. We know it's been trained on some news and is of the size medium, right? So we just select the model that we are interested in, and we apply it to our spaCy tokenizer. So this is the basic how the text would look like. So we have our original text that has been split segmented into single tokens. And you can see this, for example, by the fact that even every element of punctuation now it's basically a token itself. We now continue in the enrichment phase. We attach basically part-of-speech tags. For that, we use the spaCy post tagger, and we pass on the model that we selected originally here with the spaCy model selector onto our spaCy post tagger. And obviously, we also need to pass our input data. As you can see now, we are able to determine which token in our text is a noun, which one is an article, which one is, for example, a number. Then we continue, for example, with the lemmatization. As I said at the beginning or before, the spaCy lemmatizer, what it does, it basically reduces the token to this root form. And in fact, we can see, for example, here, we now observe the base form of the verb to be in Portuguese. Well, before, here in the spaCy post tagger node, we obtain simply a tag as part of speech tag. And this verb, in this case, was conjugated into the past tense. And then we continue with a stop filter, with spaCy stop filter node. Here, we just simply filter out stop words. So very simple. And we continue, for example, by transforming those tags into vectors. Why do we do this? Maybe we want to, for example, train a machine learning model, but we'll see more about this in the use cases. And so, as you can see here, now we have a table with basically some vectors in it. And finally, we decide to, for example, extract only those tokens that have been tagged as nouns. And for that, we use a tag filter node, which is a node of the KNIME native text processing extension. And every time we want to have a look at how the text looks like with the tags, we can simply use the tag document viewer node. Very simple, as you see basically here. And with that, I would like to leave the stage to Artyom, who is going to introduce a few use cases in NLP that combines spaCy nodes and KNIME text processing nodes. Take it away, Artyom.
Yeah, thank you for introducing the how to use KNIME nodes and the introduction of all those nodes. And yeah, here we go. I guess my screen is now visible, right? All right, so the main intention in order to develop those nodes was to basically combine spaCy capabilities with KNIME capabilities, because I've been working with spaCy before those nodes exist, and I was thinking, okay, how can I combine these two things, nice things together? Because let's say KNIME, they already have native text processing extension that already have some methods for text analysis, such as topic modeling or term co-occurrence. And KNIME operates with a special data type called document. So that was the idea, in order to make all these things meet together, spaCy and KNIME. And today I'm going to present you two use cases and two workflows that are available on Hub. They are described in blog posts or webinars. So if you would like to see some details, please go ahead. So the first one is more like entertainment workflow that I created when I was testing and learning these nodes. So it's a Breaking Bad subtitles analysis when I just took a corpus of the subtitles for all the episodes and seasons of this series and try to analyze it. And after that, here comes news relevance workflow that we presented a year ago. So this is a more business use case or real project when actually I applied almost the same techniques, but for real data. So let's just briefly, I will just briefly explain what all these workflows about, and then I will present them. So the idea for Breaking Bad subtitles analysis was to just try out how spaCy node works. So basically it was like a test, and apply different unsupervised machine learning methods such as topic modeling and clustering just to see what I can potentially get out of this corpus of texts. The second goal was to create the dashboard where I could present these results and analyze them somehow. And I also decided to build a very, very simple knowledge graph, one can say, just visualize how the episodes, seasons, topics, and the terms that form those topics are related to each other and what they have in common, or maybe there are some unique topics. And of course, it was just to entertain myself, and I really hope entertain somebody else as well. In case you are interested in more details, you can read the blog post that I wrote a couple of years ago. So the outputs, yes, as I said, I have built the interactive dashboard when I presented the output of clustering into two projections by PCA and TSNE, so I can try to understand what type of, how different episodes were grouped. Then I have built the tag cloud based on the most significant terms in terms of topic modeling. I have created a sunburst diagram that shows the connections between the seasons, topics, and the clusters that I have obtained, just to understand, let's say, which season was more uniform or more diverse or scattered in terms of topics. And yeah, there was a graph that represents the relationships between the terms, the topics, episodes, and seasons. Basically, it was quite organically that we had a business use case with QFCRA, Qatar Financial Control Authority. And to be honest, they just provided their texts that's mostly dedicated to financial sector, banking, stocks, this kind of stuff. And we started applying similar techniques, both for unsupervised and also supervised machine learning, because supervised machine learning, they had a problem where they would like to identify the relevance of the texts, while the relevance was basically defined by the people who work there, and this was their collective opinion whether the text is relevant or not. And again, there was a webinar a year ago, last September. So if you are interested, you can watch it on KNIME TV. So the output, again, was pretty much similar. So we used TF-IDF metrics to identify the most significant words for the whole corpus of the documents. We built the tag cloud based on this. We also created the diagram that shows the importance of the terms for topic modeling. And we also created the co-occurrence graph just to see what kind of connected components or like separate topics we might have in this corpus of documents. And finally, yeah, we have trained the model that helps in identifying the relevance of the texts, and it's possible to validate the model just to see the scores, see the predictions, and so on. That's pretty much it. So now let's switch to the demo. So the first example, Breaking Bad. So yeah, all those workflows, they are available in Hub. So I guess after that you will get the link so you can download them. The first example, basically I downloaded the subtitles for each and every episode of Breaking Bad. And in the first top parts, what happens here is that I just list these files somewhere in the folder that within the workflow. And then I do some simple processing. So I'm reading the subtitle file itself, and I also extract the such categories as season and the episode number. And also I do very simple processing, such as removing the HTML tags. So no interesting stuff here, just processing. The second part here, where spaCy comes into play. So as Roberto already explained how to use this node, you should always start with spaCy model selector. In that case, yeah, I've been using one of the small English models, so you can select them by language, by version, and so on. Then you can propagate the model using these blue ports. So the first step is tokenization. Basically, we need to read the text from their raw format, basically the string format, into tokens. So we need to split them, all the tokens, and not just tokens, but also punctuation. After that, we have the column of a document type. It's not visible, but it can be visible with special KNIME nodes such as document viewer. And after that, I apply named entity recognition. So let's have a look how it works. So here is a document viewer where it allows to select some text. So then in the pop-up window, we can see the text itself. If we go here and select spaCy NE tags and make them visible, we are getting them on the screen. So, and spaCy can recognize quite a lot of different types of named entities, person names, company names, locations, sums of money, dates, pretty much a lot. So, and after that, I remove the names, locations, and organizations, because the idea was to keep only the most meaningful and the core tokens, so the algorithm are not distracted by these special terms. After that, I apply standard classical NLP processing, such as erasing punctuation, erasing stop words, make case conversion to lowercase. Then I apply a part of speech tagging, and then it is used in order to only keep the most meaningful words for the whole corpus. And basically it's nouns, verbs, and adjectives. And finally, I do the lemmatization. So as Roberto explained, this is just bringing the token into its root form. And as long as I'm going to apply clustering, I do the vectorization. So then these texts, they are converted to the embeddings. So these are big vectors that I'm going to do, that I'm going to use for clustering. And after that, there are two branches. And the first branch, I apply k-means, and I also do some dimensionality reduction with PCA and tsni. Yeah, and on the second branch, I iterate over each season and try to find the topics for each season independently. After that, I combine the results, and I'm getting those results that were actually previewed on the slides. So as long as I have applied simple clustering methods, I can see that, okay, so yes, there indeed was some clustering, and even in these PCA and tsni projections, we can see that the episodes, based on their content of the subtitles, they diverge a little bit. To be honest, I haven't seen, the last time I was watching Breaking Bad was 10 years ago. I don't exactly remember, so I cannot properly interpret these results, but I think for true fans, this might be helpful. Then we have a tag clouds that shows the most frequent words in terms of topic modeling. And here, this diagram just shows us that distribution, basically per season, the clusters that have been obtained for text embeddings, and also the topics that were obtained by topic modeling. And also you can see which episode belongs to this topic cluster, season, and so on. Just a rough analysis says that probably it's not visible, but this is season 5. It seems to be the most diverse season, let's say comparing to the season 2 or season 3. Well, no surprise, that was the last season of the series, and there are a lot of events going on. So very simple analysis. And finally, there is a season topic matrix that shows the topics that were obtained per season, containing the words that form those topics. So that's it. And yeah, and also we have a graph that shows, at least it helps in analyzing how unique certain topics for certain episodes or seasons are. So for example, here in the middle, we have highly connected nodes such as mean, time, okay, talk, guide, tell, look. So it seems that these terms occur quite frequently among multiple topics, among multiple episodes and seasons. But let's say here we have sort of an outlier. So it's season 5, topic 1, that seems to have quite unique terms that belong to just one single, just belong to season 5. So this is a very, very brief explanation and analysis. And let's say if you're a fan of Breaking Bad, maybe you're welcome to try it out, or you can try to download your own subtitles and apply the same analysis and find some interesting here. And the second demo for today is the news relevance training. So this this use case is split into 2 parts, the training and deployment part. So what we have here is the list of different financial related documents. Each has the raw texts, the article ID, a unique ID, and the relevance label. 0 stands for irrelevant, 1 stands for relevant. So what we do here is, again, we just encode this number representation of relevance as categorical representation. And then in this component, we apply both processing and also the analysis, such as topic extractor, term co-occurrence, and TF-IDF calculation. So basically, the procedure is pretty much the same. We use tokenizer in order to convert raw strings to documents, and within this subcomponent, we just do some processing, such as filtering the numbers, punctuations, delimmatization, and vectorization of the text for further machine learning. And yeah, so we are extracting 10 topics with 10 terms. We calculate the TF-IDF, which is a standard metric for term significance. So we just multiply term frequency by inverse document frequency, and this metric gives us the most relevant and significant terms in the corpus. After that, here comes the component that represents the results of, let's call it unsupervised machine learning methods. So let's say here we have the top 10 terms that occur, that have the highest weight among the topics. And let's say, yeah, no surprise, we have bank, market, financial, but let's say on the other hand, we have stock, digital, inflation. So considering the text what we have, no surprising that we have those words here. So the tech cloud shows the words by their TF-IDF metric. And here we have, okay, material. It seems that we have a lot of documents describing different types of materials. There also, I remember, it's possible to see some company names and city names. And of course, the size of the tag is represented by TF-IDF metrics. So basically, the bigger, the more important. And again, we have another graph called occurrence graph that shows different connected components of the, and no surprise that we have two of them. Basically, it actually correlates quite well with what we have here in top terms, because we have some documents related to bank and markets, and we also have some documents that are more related to stocks and shares. So that was like a unsupervised machine learning analysis. What we do next is that we take those vectors that we created during the pre-processing and we split them into a separate column. So after that, we can feed these basically vectors to a machine learning algorithm in order to train the classification model that will help us to distinguish relevant and irrelevant texts. So we do the partitioning for training and test data set. The ratio is 80:20. And then we just have like a very simple toy competition between two models, decision tree learner and random forest learner. So what we are trying to predict is the relevance, and the only prediction features that we are using are the text embeddings, basically the vector representation of the text. And after that, we have the component that help us to evaluate the predictive quality of the models. And to be honest, there is no surprise that random forests beats the single decision tree. Usually it happens like this. Here you have this binary classification inspector where you can analyze change in the threshold, or maybe you would like to find the optimum, let's say the maximum F measure for each of the models. So you can switch here. You have the statistics for each model performance. You have confusion matrices. And yeah, no surprise, if we take a look at the overall statistics, so for decision tree, we have just 62%, for random forest, we have 73%. Coin kappa is also way bigger for random forest. And if we take a look at some other metrics such as F measure, random forest beats decision tree. And here we have the table with the assigned prediction tags, and we also can compare where the predictions were right or wrong, because we have true labels, and we also have the class probabilities for each of the models. After that, we select random forest to be the best model, and we save it. And then we have a deployment workflow that actually repeats most of the steps from the previous workflow. The only difference is that now we have the data set that does not contain the labels. Basically, this is like a business use case scenario. Now we are applying our model in order to make those predictions. So in order to do this, we partially do the same thing that we did previously. The only thing we don't do is just this analysis using unsupervised machine learning methods. So we only do the same pre-processing. So then we can feed the same vectors, process the same way to the same model. And after that, we can get our predictions. However, here we can only see the text itself and the label assigned by the model, as long as the class probabilities. So yeah, that's pretty much it. And I guess we can move forward. So Roberto, please.
Yeah. Hi, Artyom. Thank you very much for showing to us these use cases. Very insightful. Thank you very much. And we are now reaching almost the end of our webinar. Before we move to the question and answer, I'd like to call Raphael back on stage, because he's going to talk about what is, let's say, what is new and cooking for spaCy, for the spaCy library in terms of LLMs.
Thank you, Roberto. All right. You do see my screen?
We do.
Excellent. Okay. Well, what's new in cooking in spaCy and also in Prodigy is, not very surprisingly, large language models. So we have been working quite a bit with large language models, like all those GPT variants, and looking into how they can complement spaCy's functionality. So coming back to this example we had before with the clinical trials, right? So I illustrated or described all of those different steps and basically told you need to create a model, you need to label the data, you need to write a config for training the model, and then you finally have your model, right? These are quite a few steps. So if you now want to use ChatGPT for something like that, for example, you get an output that is already somewhat usable without any of the setup. So this is pretty nice, right? This of course comes with a few disadvantages as well, like specifically ChatGPT lacks a few things that you would like to have in production, right? That's not an API. There's no batching. It's a lack of robustness, lack of data privacy, recursability, etc., etc., etc. But in general, large language models are quite a versatile, flexible, and capable tool. So I like to compare them kind of to a Swiss Army knife. Like they can do a lot of things reasonably well. If you really want to go, if you really have a business case and you really want to have something efficient, then smaller specialized models are still better or can be better, faster, and way cheaper. So it's a question of priorities and a question of how much data throughput you have in practice. Now, spaCy LLM, that is a spaCy extension that integrates large language models into your usual spaCy production-ready structured NLP pipelines. So we use large language models to complement spaCy functionality, to add some new functionality that spaCy doesn't support out of the box by itself. And for that, we support external hosted proprietary APIs, such as the OpenAI API, Cohere, or Anthropic, as well as open source models such as Llama 2 or Falcon. Each of these models, there are different pros and cons to that. I'm not going to go into that because that would be a whole webinar on its own. But it's rather easy to use spaCy LLM to connect to these models or APIs, and you can have your spaCy pipeline using those LLMs quite easily using the spaCy config system. So what happens is that spaCy LLM offers predefined prompts that are sent to the LLM to solve a certain task, such as, I don't know, sentiment analysis or text classification. The LLM sends back a response. We parse the response and then turn this free text response from the LLM into structured annotation in the spaCy document objects. So we take care of all of that, so that in the end you end up with an object, with document objects that actually are structured data, which is important for further downstream use cases. There's a lot of freedom in how you customize that as well, but we offer a lot of built-in, out-of-the-box support for different tasks and different models. And coming back to this free stage idea for how we see the spaCy philosophy, essentially, LLMs make it way easier for quick prototypes. Essentially, it's way faster to prototype stuff nowadays by using LLMs because you often, depending on your use case, depending on the data you have, you can often skip this first model training step, right? You can just plug in something like the OpenAI API, or better, an open source model, and this large language model will be capable enough to give you somewhat reasonable results for a lot of use cases. So it can prototype very quickly. But again, as I mentioned before, depending on your use case, you might still want to switch to custom locally trained models for specific tasks, because these are still to this day more accurate, faster, and way cheaper, especially compared to proprietary hosted LLM APIs such as OpenAI. The rest of this whole spaCy philosophy remains the same. It's just that we use LLMs to be more flexible and to allow for faster prototyping of your production-ready pipeline, or soon-to-be production-ready pipeline. So the development cycle here would be you do a quick prototype with the LLM, you look at it further into the refinement phase, you integrate it or replace it with supervised machine learning, so locally trained models, some rules or some other stuff that make your pipeline more efficient. You can then fine tune it. And this is where you then finally get the business value out of that. So LLMs are great for for speeding up this development cycle and for introducing more flexibility in that. So just a quick recap. So natural language processing, what it does, it unlocks information and further downstream business value from natural language, free form text. And it does that by extracting structured data from unstructured data. Large language models are very impressive, their capabilities for generating text and for understanding free-form text, and that also made it super easy to prototype natural language processing applications of LLMs. But LLMs do not solve that entire field by themselves. They speed up the whole development process. They replace more or less classical NLP for some use cases, but LLMs do not have the performance that classical models, that locally trained models do. So when building a production-ready pipeline, you need to consider various properties here, like LLMs, for example, are super slow compared to local models, to smaller models. Then you have to pay for API calls. Then there's robustness, customizability, observability. So there are a lot of factors that come into play when you decide for or against the model for production-ready pipeline that you're actually going to use in production, not just for experimentation. spaCy is a production-ready natural language processing framework with a focus on developer satisfaction that can handle these production use cases, and its base LLM extension allows the integration of LLMs into this framework that spaCy provides. And finally, also what's cooking with Prodigy, the labeling tool I mentioned before, it's also LLM-assisted annotation, meaning that instead of labeling all the data from scratch, what you can do with Prodigy is you can use LLMs to automatically pre-label your data for you, and then you just have to review whether this data is correctly labeled and fix any labeling mistakes that the LLM did. So this also speeds up label or data annotation by a lot if those LLMs are integrated properly. That's it for me, and Roberto is gonna continue from here, or Artem.
Thank you very much, Rafael, for letting us know how spaCy is now integrating for LLMs, and how can we also integrate this. Let me just share my screen. And again, in KNIME, that's also something quite new that was introduced with version 5.1. By the way, we saw before with the nodes that there's also, in the spaCy node, there's also Python tab. So there's also another option, for example, to also integrate what Rafael was just presenting in your KNIME workflows using those spaCy nodes. But how can we just leverage LLMs if you don't want to write a single line of code? We have a quick overview of how we can leverage LLMs in KNIME 5.1, either by building our KNIME workflows with using the KNIME AI Extension Lab, for example. So we basically build a usual KNIME workflow, but we leverage those models, or thanks to a built AI assistant in an analytics platform. So it is within the platform, and it requires installation of the KNIME AI Assistance Lab extension. So if we talk about the extension to build workflows, here you see on screen a few collections, well, a few nodes, the nodes that are part of the extension. And what can we do with those nodes? Well, we can basically connect and prompt large language models and for chat or for embeddings, and we can basically leverage models hosted either by OpenAI or open source model hosted by Hugging Face Hub. And if we want to run some of those LLMs locally, we can also leverage the open source initiative of GPT-4o. We also have nodes to work with vector stores such as Chroma and Face, and we can even kind of bring together the vector stores and the LLMs and sort of train and prompt specific agents that can answer sort of a more specific question to our business problem, for example. And here I just show you a little example workflow that will be shared with you as well, how we can leverage, for example, open source model or closed source like OpenAI. So we basically, in one case, we connect to Hugging Face Hub for the open source option, and then we select the LLM that we would like. And the other case, we use a closed source option, basically OpenAI. We select, in this case, ChatGPT, and we build a simple, very simple workflow to predict sentiment. So very simple. As you can see, it's just a bunch of nodes. The other option, as I said, is to actually leverage the built-in capability that KNIME Analytics Platform version 5.1 has. And this is basically with this new extension called KNIME AI Assistance Lab that allows us to basically interact with your artificial assistant and to ask for help to answer KNIME-related questions. So selecting the tab Q&A, or you can switch to the tab Build, and this will allow you to basically prompt your artificial intelligence to help you actually build a workflow for you. You only need to be logged on the KNIME Community Hub and basically start using it right away. And with this, I'll just go to the summary. So we just, throughout the webinar, we learn about what spaCy is, how we process and understand texts. We also saw how the Redfield developed an extension to bring basically the power of spaCy to KNIME users. Our team basically walked us through a few use cases to use basically to combine the power of spaCy and KNIME native text processing nodes. And finally, we saw basically what's new in spaCy and KNIME in terms of LLMs. You will find all the workflows at this link, and the slides will be shared with you in the follow-up emails. And with that, I will go to Q&A session. And for that, I'd like to stop sharing and to invite my two co-speakers to switch on the camera so we can address some of the questions that were asked in the chat. I think there are a couple interesting questions for Raphael first. Somebody's asking whether those clinical models that you showed at the very beginning are available in Spanish. Is the first question for you, and somebody's asking if you can repeat the name of the tagging tool that you showed at the beginning as well.
Those clinical models are not available in Spanish. They're also not available in English as well. That was more a use case demonstration that we did internally. The models that are available for those 24 languages that I mentioned before, these are models that are trained on publicly available mixed web or newspaper content. So it's more like general knowledge, general domain data and information is incorporated into these models. We do not offer domain-specific models as pre-trained models. So much for the first question. The second question is the tagging tool, the annotation tool. That's called Prodigy. Maybe Roberto, maybe you can include a link to Prodigy in the final mail. Yes. that you mentioned before. It's called Prodigy. It's the website is prodigy.ai if you want to have a look. Would be nice. Looking forward to your questions.
Nice. Thank you very much, Raphael, for answering that. And I think there was a question that was already answered by Artem. I just repeat it once again. Somebody asked whether it was possible to add new languages that are not immediately supported by the node when you configure the model selector node. And yes, it's possible. There is an option to import local models, right, Artem? You want to add something else to this?
Well, perhaps I can just briefly show how it looks in KNIME. Sure. So here we have a model selector. You just open the settings, then you go to local model, and then you can specify where exactly your model is located. I'm not sure if I have one like a customized, but let's say I definitely know that there were some models that were trained on biomedical scientific papers texts. So they were capable of, let's say, extracting the names of genes, diseases, and chemical compounds, just for example. So yes, it's possible. If you have your own maybe customized or trained model, as Raphael explained, it's possible to train it. Just use this mode, local model.
Great, thank you very much. And there was also a question about whether it's possible to use the spaCy nodes in KNIME in version 4.7, and it is possible. Is that my answer is to be yes, but then I want to confirm with Artem.
Yeah, just one note. At the moment, it's in experimental repository, so you have to go to KNIME settings, then go to update sites, and then you need to click on this checkbox, use experimental. I really hope we are working on this, that soon it will become like a general availability repository, but at the moment it's in experimental. But yeah, now they are available for 5.1 as usual.
Perfect. Thank you very much. I think time is up. I think there were a few more questions, but they were already answered and addressed by either Artem or Raphael. So I would like to thank all of you for joining this webinar today. Thanks to Artem and thanks to Raphael for being with us, for making time to be with us. And thank you, obviously, to all of you who joined our webinar. And as I said, the recording will be available, the slide will be available, and will be shared with you in the follow-up email. Thank you very much, and stay in touch.
Yeah.
Bye-bye.
Bye.
Thanks. Goodbye, everyone.
Bye.